here's the kind of question you will get. Okay. And the question is, how do you phrase this recurring decimal as a fraction? Just as a point of interest, right? And if you remember this from like year 8 when you first meet them, all recurring decimals, no matter how long it takes them to recur, all recurring decimals and all terminating decimals, they're all fractions. Every single one, right? If it doesn't recur and it doesn't terminate, it's not a fraction. It's irrational. And the most common examples of those are surds. They're not all, pi, e, and so on. But anything in this form that repeats you can write as a decimal. Does anyone know what this particular one's equal to?
2/9.
It's 2/9. Okay. Now, that's the answer, but how do you get it? Now, there's a couple of ways I'm going to show you. We'll deal again with recurring decimals when we meet series and sequences in year 12. But there's a fairly simple way that you can argue this out using algebra. Okay, so here's the way that you would set it up. You would begin by saying, let this thing that you've been given, well, let's give it a name so that we can work with it, okay? So if x is equal to 0.2 repeater, that's equal to, 0.2222, and so on, okay? So that's another way of writing the same thing. It's rather less efficient, but it's helpful to me because my next step is to say, well, I want to work with this thing and be able to do some, division on it, right? So in order to compare this with something that's helpful, I'm just going to multiply it by 10. Right? Now, the reason why multiplying by 10 necessitates me writing it out like this is because all you need to do to multiply by 10 is move a decimal place. That's all you need to do, right? So if I multiply this, I'll get 2.2222. And they're all there because there's an infinite number of them, okay? So now what's helpful here is that if I say, okay, this line minus this line, they're almost exactly the same, right? Can you see in there? Right? There's this thing and this thing which are identical. Okay? So if I call this, you don't have to. I'm just doing this for your own illustration. If I say line 2, take away line 1, 10x minus x. Right? I'm going to have 2.2222 ... take away 0.2222 ... and all I'm left with is, well, 9x on this side, 2 on this side. And you're done. Okay? Alright, Liz.
If it's like x equals to 0.999, so the result will be x equals to 1.
Correct.
Why?
Well, I'll refer back to this. The real problem is this. This is the real problem. That's the real problem. Like, if I say something is equal to, if it really goes on forever. See, we're getting at an issue now, excuse me. I can say, right, that there's an infinite number of 2's trailing off on the end here. The subtle problem with that is that infinity is not a number, right? It's an idea, it's a concept that it goes on forever. I can say there are 100 2's or 1,000,000 2's, but to say there's an infinite number of 2's, it's a bit of a misnomer. What does it really mean if the 9's go on forever, right? Well, let me put it to you in another way, right? If I had, say, the number 1, right, and I said to you, what is the difference if I take away this from this? If I say this minus this, what would your answer be? Right? Now, but you have to justify that, right? Now, the reason why I can't say it's 0.1 or 0.001 or 0.00 is, get this. Just like these 9's go on forever, in my solution, these 0's are going to go on forever. Like you might say, oh, but there will be a 1 at the end. There's no end. It goes on forever. That's what forever means. Okay? So being that the 0's go on forever, this number over here is 0. So this is equal to this. Okay, now we have problems with that because symbolically it looks wrong. Because you're like, look, this is 0 point something, and this is not 0 point something. But that's you're right at the cusp of where notation, right, starts to break down what something actually means, and it's kind of a special case. Yeah?
If you do it as a fraction, it makes no sense. Just saying.
Would you like to explain?
Well, like, if you... I don't think I can explain it very well.
Well, I mean, look, to get to this result, it's just as easy for me to start with a 9 everywhere that there is a 2 written here. And you will come out quite clearly with
9 on 9.
x is equal to 1. Because it'll be 9 on 9,
Yes.
right? So I can argue it that way, but people still, like, it's because of the way this looks. It's completely about the way it looks, right? Yeah, 0.9 repeater is 1. And there are other ways I can argue it, but I think that's sufficient for now.